Alright, we're in section 3.3, the conditional. I did pull up the text. Kind of wanted to point out a couple of terms as we go through this. We're going to be writing conditional statements. Conditional statements use connective if and then. Okay, so we're going to be doing things in the if, P, then Q form. You have implies, then. The statement consists of P, the first part, which they call the antecedent, and Q, the consequence. Okay, so they give you several examples, which it'll be good for you to go through some of these. They show other examples in the scenario where it's true, the antecedent is true, and the consequence is false. And understanding the truth value of an if-then or conditional statement. And just want to point out a few more definitions. So they show the characteristics of the conditional statement when it's false. So P implies Q, if then is only false if the antecedent, the first part, is true and the consequence is false, which is the second part. And so they kind of go through several terms and show you some truth tables. So familiarize yourself with some of these, but I'm going to try to do 2 examples of each, since there's only 7, to give you a little bit more insight. They're not always what you think, so it's going to take some time and practice to get them down. So we have a statement: all rational numbers are real. And when you write it in if-then form, you want to make sure the statement is true. The statement has to be true. So all rational numbers are real. That's what we're given. All rational numbers are real. If a number is rational, then it is never real. That's not what this says. It says it's real. If a number is real, then it is never rational. This kind of flip the order. Sometimes that happens, but that doesn't say the same thing. And then C, if a number is rational, then it is always real. So all real numbers are rational. Kind of comes with that territory. So C would be the best answer here. Okay. And then I'm going to come back and I want to do a similar one just to see a difference. And it looks like the same thing. All irrational numbers this time. All irrational numbers are real. And if a number is real, then it's never irrational. If a number is irrational, it's never real. If a number is irrational, then it's always real. So it's almost the same example. It just went from rational to irrational.